All right, friction. Everything we do is affected by friction. People are always interested, engineers are always interested, getting friction smaller, if I'm trying to get a machine to work by putting oil in it, or smaller. People are interested in getting it bigger, like people who make snow tires. Um, Constantly on our mind. So friction is a force that, don't want purple, resists motion and always acting in the same direction. It always acts opposite to the direction of motion. A few different types. Static friction is the friction on a stationary object. That prevents it from moving. That keeps it in place. And this amount can vary. Starting friction is the maximum static friction. And if static friction has reached its biggest amount, the object usually will start to move. So we call this the starting friction, maximum static friction. And then kinetic friction is friction on a moving object. Oh. And there's a few different kinds. If we think about things that move, we can have rolling kinetic friction. We can have sliding kinetic friction when things are rubbing against each other. Or we can have fluid kinetic friction, like when a submarine moves through water or a plane moves through the air. All just different types, just to keep them in mind. How do I calculate it? This is the formula here. Force of friction is equal to mu Fn. Force of friction, we measure this guy in newtons. The normal force, it's another force, we measure it in newtons. Mu, if I was to rewrite this formula and solve for mu, I would get that mu is the force of friction. Right now I'm multiplying, I bring this guy over and divide. Yes. Units on the top are newtons. The units on the bottom here are newtons. I would cancel out the units, so mu has no units. Mu has no units. And it's a measure of the friction between any two surfaces. And if we look in our textbook, we can find a table of different mu's for different surfaces in contact, like steel on ice, if I was interested in doing a question with somebody on skates, or rubber on concrete, if I was interested in doing a question with tires on a road. So if you're doing a question, you're not sure what mu should be, and the question's not asking you for mu, you might go to that table to get the data that you need. Notice in here, there's no surface area, right? Surface area does not matter. Okay? It's only about what are the surfaces in contact and how hard is this object being pushed against, how hard are the two objects being pushed against each other. So here's a question we might try together. We've got a crate, dragging it across the floor, pulling a rope on the rope. I've got a mu. What is the minimum force required to get this crate moving? So, as with all force questions, we are going to make a free body diagram. see here the mass is 68 kilograms. What forces are acting on this guy? I'm going to draw my arrows in a different color. Well, as always, I've got force of gravity down. Yes. I've got a normal force up. And these things are equal. I'll just write that over here. Fg is equal to Fn, since it's not, the crate's not jumping off the floor or going into the floor. If we assume that the rope is this way, we can call this tension or applied force, doesn't matter. And going backwards here, I've got some friction. I know that mu is 0.47, and I'm asked for what's T got to be. So in A, it's asking for T equals what to move crate. When is this crate going to start moving? When is it going to start moving in this diagram? When T just gets a tiny bit bigger than friction. So I'm looking for when T is greater than the force of friction. So I will, so the tipping point is actually when T equals the force of friction. Right? So I'm going to, force of friction is equal to mu Fn. And we already decided that Fn is equal to the force of gravity for this thing. And we know from our earlier studies that the formula for the force of gravity is m times the acceleration due to gravity. So I'm going to plug these guys in. I got 0.47, I got 68, and I got 9.8. And I get out my calculator and I get 313 newtons. That's how much force I need to get this guy moving. Part B says, okay, and after something gets moving, that's a good point. Let's go back up here. Is that, let's go up here. Static, I'm going to write it in red here. Static is always greater than kinetic. So after I get this thing moving, this block moving, the amount of friction that's acting on it always drops down a little bit. It's always harder if I'm getting something moving to get it moving. And after it's moving, it just feels a lot better. It's a lot easier. So in part B, the mu drops down to 0.29. How fast is this going? So, in B, mu is now, let's say 29? And I'm interested in what is the acceleration of this crate. So I'm going to write an equation for net force acting on this crate. I go up here, net force acting on the crate. Well, it's going this way, true? So I'm going to put T minus force of friction. And then in the next line, whenever we're doing these questions, I replace F net with MA equals T minus U M, or I'll put Fn, and then I'm going to put 68 as the mass, A equals, I'm still pulling with this force, right? It's coming over. 313 minus 0.29. Now, Fn is still equal to mg, so it's times 68 times 9.8. And now I'm going to solve for a here. So I'm going to do this math, and then I'm going to subtract these numbers, and I'm going to divide by 68. And when I do that,